Dr. Jagadha Saravanan, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about formation of partial differential equation by elimination of arbitrary constants. In this lecture, we are going to discuss about definition of partial differential equation, dependent and independent variables, and how to eliminate arbitrary constants. Partial differential equations. An equation which involves one or two partial derivatives is called PDE, that is partial differential equation. It must contain at least one dependent variable and two independent variables. One dependent variable and at least two independent variables. Dou Z. In this, dou is playing the role of partial differential equation and Z is playing the role of the variable dependent. X variable, they playing the role of independent, and dou Z by dou X, it is noted as small p, and dou Z by dou Y. Dou represents partial, Z dependent variable, Y independent variable. Dou Z by dou Y is noted by Q. So according to the definition of partial differential equation, one dependent variable. So if you are noticing dou Z by dou X, dou Z by dou Y, in this Z is the only one dependent variable and X, Y are two independent variables are there. Dou squared Z by dou X square, the notation is small r. That is 2 times it is differentiated partially with respect to X. Dou represents only the differentiation with respect to partial. Here dou Z by dou X. One more time we did the differentiation with respect to X. That is the reason here dou square it is there. Next, dou Z by dou X equal to P. Here dou Z by dou X, again it is differentiated with respect to Y. That is denoted by capital S. Dou square Z by dou Y square is noted by small t. So these are the notations we have to keep in our memory, that P represents dou Z by dou X, Q represents dou Z by dou Y. That is only one time we are doing the differentiation. This is partially with respect to X. This is partially with respect to Y. Here, 2 times we are doing the differentiation with respect to X and it is small r. Here, 1 time with respect to X, again with respect to Y, it is denoted by, it is small s. Dou square Z by dou Y square, that is with respect to Y, partially 2 times it is done, it is noted by T. So these are the notations are going to play a role in partial differential equations. How to do the partial differentiation? Some basic examples are kept here. Suppose Z equal to X plus Y. We want to do this with respect to X, we want to do differentiation partially. If dou is playing a role, compulsory differentiation partially. it gives an indication that dou. So dou z by dou x. That means here x, y, two variables are there. That means the 2xy, two variables, they are independent variables. That is the main thing we have to note it down here. X, y, they are playing the role of independent. Our z is playing the role of dependent. So any variables are there, first our main thing we have to cast the point that which is dependent, which is independent. Now x and y are independent, z is dependent. The point is very clear. Fine. Dou z by dou x we want to do it. So here z is dou z by dou x. X we are doing the differentiation 1. Y, the differentiation, it has become 0 because partial differentiation means here with respect to x only we are doing. Only x we are concentrating, only we are favoring x. Whatever other variables are there, we will neglect it. We will treat them as constant. Then it will become 0. So in that angle, so we are favoring, we want to do partial differentiation with respect to x. That is the reason x is 1 and y is becoming 0. Now we want to do the partial differentiation with respect to y. Then x is becoming 0, y is becoming 1. Next, one more a small example. Z square equal to x square plus y square. So this left side, we know the differentiation formula, that is x power n means n x power n minus 1. This is the formula. So our n is 2. Our n is 2. So z square 2z. Again z we have to do it. The differentiation is dou z by dou x. X square differentiation is 2x. Partially with respect to x we are doing. So other variables we have to neglect it. Other variables in the other independent variables. You can see it. So this is y is becoming here 0. So this part is very clear. Here we have done it partially with respect to x we did. Now we will do partially with respect to y we will do it. Fine. So z square 2z dou z dou y. Fine. We are doing now partially with respect to y we are doing. Then x is 0. Y square is 2y because the formula we know it, n into x power n minus 1. So here y is there, n into y power n minus 1. One more example we will see. These two examples, x plus y, x square plus y square. So the operation plus addition played a role. Whereas the third example, x square into y square, then we have to be very careful. How to do? Now, z square is there. With respect to this is partially with respect to x we are doing. So 2z, z again dou z by dou x. Here x square, the differentiation is 2x. Before the two cases, y square, if it comes wherever y, we put it 0 when we are concentrating x. If we concentrate x, y has become 0. When we concentrate y, x has become 0. But why not in multiplication? Because the first two examples, addition. But here it is in, they are the two variables, they are connected by multiplication. So when the multiplication is there, now partially with respect to x, we will do it. We will apply the formula. X square is becoming 2x, but y square should be written as it is. Similarly here also, now with respect to, now we will do with respect to y. So the left side 2z, dou z by dou y. Fine. Y square is 2y. But both the variables are connected by multiplication. That is the reason x square is treated as constant and it is written also. That is the main difference between these three small examples. So here 2x square, y should be written. So this is the basic differentiation formula. Now, form the partial differential equation by eliminating the arbitrary constants a and b from z equal to ax plus by plus a square plus b square. This we have to do it. First, this given equation we are naming as 1. The notations already we discussed it. That is dou z by dou x equal to p. Now we are differentiating this equation 1 partially with respect to x. So we can write it better here. This is the question that we named it as 1. So the equation 1 partially with respect to x. Yeah. Now left side is z is there. Partially with respect to x means dou z by dou x. Wherever x is there, we will do the differentiation. Any other variable, they are treated as constant. So ax is there. So a is written, x differentiation is 1. This by, we won't consider at all because we are doing partially with respect to x. And this is also 0, this is also 0. So we got it, dou z by dou x equal to a. And we know the notation, dou z by dou x equal to p. We are naming as equation 2. So p equal to a. Main our question, whatever the 5 notations we discussed, what is p, what is q, what is r, what is s and t. Anything we will do, final, the required solution, this a and b should not be there. Whatever we can do it. Next, differentiating equation 1 with respect to y. So this is the equation, question. With respect to y we are going to do. Then other things are all treated as constant. So we know it. This left side, dou z by dou y. So this x variable, it is connected. So it has become 0. B as it is. Y differentiation is 1. And a square 0. B square is 0. So we got it, dou z by dou y equal to b. This complete one which is equal to q. Why here q is written? What purpose? Because already the notation we discussed it. Dou z by dou y equal to q. Now the equation 2 we got it. P equal to a we got it. Now equation 3 we got it, q equal to b. Equation 1 it's nothing but our given question. So these two, equation 2 the what we got it, p equal to a, equation 3 what we got it, q equal to b, we are going to substitute in equation 1. Yeah, we substituted it, p equal to a. So a is replaced by p and we got it, q equal to b. And Here we can see a square is replaced by p square, and we can see it b square is replaced by q square. So is the required partial differential equation after elimination of two arbitrary constants a and b. So one more problem we can concentrate. Eliminate h and k from, this is the equation it is given. They told remove h and k from the question. The five notations are there. P, dou z by dou x. Q, dou z by dou y. Similarly, R is there, S is there, T is there. Apply. Finally, you remove that h and k. This is the question which is asked us to do it. We will do it. So the given equation is, we are naming as 1. So equation 1, partially with respect to x, we want to do it. So here, x minus h the whole square. We know the formula. X power n means n, x power n minus 1. Here our n is 2. So 2, here the base is x minus h. N is 2. N is playing the role here 2. So 2 minus 1. So 2 of x minus h. Again x we should do the differentiation. X differentiation is 1. So this we completed. The second one we are noticing, it is completely y variable. Partial differentiation we are doing. We want to concentrate x. We want to favor to the variable x. Then we will neglect other variable y. We neglected, that's what this differentiation has become 0. That's what here it is not written also. Now, z square, the differentiation. 2z. Again, z differentiation is dou z by dou x. Now, actually the doubt should come. Here, the doubt should come, x minus h the whole square. That is, we applied the formula 2 of x minus h. X differentiation, we wrote it 1. Here 2 is z. But z differentiation also we can write it 1. No. Instead of 1, we are writing dou z by dou x. It is a doubt, it should come compulsory. The reason is x, y, z. The three variables. Today's the lecture. X, Y, they are playing the role of independent, whereas Z is playing the role of dependent. That is the reason here Z square is there. 2Z. Z differentiation is dou Z by dou X. This 2, this 2. Common we have taken out. That is x minus h plus z dou z by dou x equal to 0. Next step, z we pushed to right side. So this step, the 2 is missing because common we have taken, we push it to right side, it has become 0. So the balance it is written here. Now in this equation, this dou z by dou x, the notation we know it. The notation is P. So in this particular place also, we are going to substitute in this place dou z by dou x. We are going to write it as small p. It is kept here. So it is written. So we are simplifying. So dou z by dou x, it is denoted by p. So now x minus h, this plus zp, it is pushed to this side. It has become minus zp. So partially with respect to x, our given question we did, we named it as equation 2. Now, the same that given question, equation 1, partially with respect to y, we will do it. This is our question. The first thing, with respect to y, we want to concentrate y. We want to neglect other variables because we are doing the partial differentiation. So x minus h the whole square, completely we will neglect it. Because the reason, partial with respect to y. That is the answer. So now, this is becoming totally 0. Here, y minus k the whole square. We know the formula. X power n or y power n. N, y, n minus 1. Again, why we should do the differentiation? We can see it. Here, n is playing the role 2. So, it is coming here. Y minus k, the whole square. So, n is 2. So, 2, y minus k, 2 minus 1. Again, y differentiation is 1. So, 2 of y minus k power 1 into 1. It is written that only. Next, z square. Same, n is playing the role 2. So, 2z. Z, I am not writing into 1. Because z is playing the role of dependent variable. That is the reason dou z by dou y. So, the students should know this dependent variable, independent variables, what are the roles, partial differentiation it is taking. That is the main thing, the difference they should know it. Yes, here we got it very clearly. X and y are playing the role of independent. That is the reason x differentiation is becoming 1. Y we are doing 1, it is coming. Whereas z means we are writing dou z by dou x or dou z by dou y. Yeah, in this 2 also, common, the two terms are there. The number 2 is common. So we have taken, so y minus k plus z dou z by dou y equal to 0. So we know it. So y minus k plus z dou z by dou y equal to 0. Dou z by dou y, the notation is q. The plus zq, it has next side we have brought it. So minus zq, it is named as equation 3. Substituting equation 2 and 3, equation 1, that is our given question. This is our given question. Our given question is this. We are asked to eliminate this h and k. Strictly it is given, remove h and k. X minus h equal to minus pz. This what we got it, the first equation 2. Equation 2 we got it, that is substituted here. X minus h is replaced by minus pz, that is nothing but our equation 2. Square, it is written as it is. Next, y minus k, just now we got it, minus zq, that is it is written here. The square, it is as it is, z square is as it is, a square is as it is. So now, the last step it is written again. P minus negative of square, we know it, positive, minus into minus, we know it is plus. So p square, z square, this plus as it is, negative square positive, z square, q square, z square, a square written as it is. In the complete term, we are noticing z square is common. It has taken out. The remaining p square, q square, the complete z square, it has come out. So here compulsory it will be 1 equal to a square. We know it mathematically always. This step, if you z square into p square, before 1 it is coming. Z square into q square, yeah, before step. Z square into 1, before step. So when the next step, if you simplify the before 1, it should come. Then we are moving in a correct way. So this is the second problem also. The question what it is asked us, eliminate h and k. So completely the required, the final notation we are seeing, completely h and k not at all there. It means we removed it. One more problem we will concentrate. Form the partial differential equation by eliminating the constants. So here they are telling a and b to be removed. Any notation we can use it, but final answer a and b should not be there. So the given equation we are naming as 1. Differentiate equation 1 partially with respect to x. The same here. X minus a the whole square. The power is 2. 2. X minus a. 2 minus 1. Again x differentiation is 1. So here we got it. 2 minus 1 is 1. So 2 of x minus a. And this is with respect to x partially we are doing. The word partial is there. With respect to which variable, only we will concentrate that variable only. That is only partial differentiation. Other variables are treated as constant. So it is totally becoming 0. Here z square. So z square it is 2z, 2 minus 1. Again z is dou z by dou x, because z is playing the role of dependent variable. Whereas x differentiation previously I put it 1. X is playing the role of independent. Here z is playing the role of dependent. That is the reason dou z by dou x we are writing cot square alpha. So this is named as equation 2. Completely. Here also 2 is there. Here also 2 is there. Both the sides 2 is common. We removed it. Now we gave the treatment to our equation 1 with respect to x. We decided to give the same treatment to the given equation with respect to y. So it is given partially with respect to y. That is the reason x minus a the whole square completely related to the x we neglected. It has become 0. That is the reason here it is not at all written. The second term is y minus b the whole square. Y minus b the whole square. We will do the differentiation partially to y minus b, 2 minus 1. Again y differentiation is 1. Y differentiation is 1. Y is playing the role of independent. So it is written here. Next z square differentiation 2z. Z differentiation again dou z by dou y, because we are doing partially with respect to y. Z is playing the role of dependent. Then cot square is written as it is. Both the sides, if you notice, the number 2 is common. We will cancel it. So it is cancelled, and this is equation 3. Now, equation 2, equation 3, both we will substitute in equation 1. That is our question. So this is our question. So x minus a, we got it. We got here, it is kept x minus a, what we got it? Zp cot square alpha. This is only our equation 2 that is substituted in this particular place. How the squares have come? Because the question x minus a, the whole square is there. X minus a, this is equation 2, but x minus a, the whole square is there. That is the reason the squares are playing the role. Next, y minus b, it is replaced by equation 3. It is replaced, but squares, it is there in the question that it has taken here. The right side, it is written as it is. Now, completely z square, here z square, here z square. Both left and right, the terms z square is common, so we removed it. The balance, if we are taking here, p square cot square alpha, here q square cot square alpha, the whole square equal to cot square alpha. So complete now, cot square alpha is common. So here cot square alpha square, it has taken. Here p square balance, here q square is balance. It is written here equal to cot square alpha. So cot square alpha, here cot square alpha the whole square, cot square alpha by cot square alpha the whole square. Here 1 is there, here 2 times is there, cancelling, we got it. 1 by cot square alpha. 1 by cot, it's nothing but tan. That is a trigonometric formula. Here cot square alpha is there. That is the reason here tan square alpha. So completely, if you are noticing the final result, there is no constants. A and B, we removed it. So we will come to a conclusion of this lecture. Linear equation, that is dou z by dou x, dou z by dou y. These are the linear equations we have taken, the notations, and the basic how to do the differentiation. Simple basic problems we have taken. X square, y square. Here x and y, we concentrated. X, y, z, 3 variables are there. In the 3 variables, what are the variables dependent? Which variable is independent? First we analyzed it. Then afterwards we did the partial differentiation with respect to x. With respect to y, we did. And we have taken the problem z equal to ax plus by plus a square plus b square. We eliminated the constants a and b. One more problem we have taken, x minus h the whole square plus y minus k the whole square plus z square equal to a square. In this problem, we eliminated h and k. Yeah, thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.